Okay, now that you've watched example 2, what we'd like to do is recap example 2 just a little bit, see what they were doing with the numbers, and then try to do this just a little bit more numerically, so when we have lots of numbers, we don't actually have to think so hard. What they showed us in example 2 was a function that's very clearly concave down. You can see that it's part of a frown, and you can see that the increases as you move to the right are getting smaller and smaller. Now, in terms of the table instead of the graph, this is what they gave us. Now, the first 2 columns was just the data. So you can see that the time in the hours is going 0, 1, 2, 3, 4, 5, and then 0, 20, 35, 45, 52, 57. Now, we saw in chapter 1 that if you want to numerically see if that second column is increasing or decreasing, you need to find the average rates of change between each of the points. And so you can see that between the first 2 points, the average rate of change was 20, then the average rate of change was 15. All these numbers are positive, so that the original function is going up. But section 2.6 is not about going up or going down. It's about concave up or concave down. Now, just a reminder, to see if this column was decreasing, I needed to add an extra column to see of average rates of change to see if these numbers were negative or positive. But now in 2.6, they're asking us to look at this last column and ask if it's increasing or decreasing. And we know from chapter 1 that if we want to see if a column is increasing or decreasing, we need to add another column and find more rates of change. So that's actually what I did over here, I think. Here? Yay, there it is. All right, so you can see, here's the original data they gave us, 0, 1, 2, 3, 4, 5, and 0, 20, 35, 45, 52, 57. Here's the numbers that they calculated, the average rates of change. You can see they're all positive, saying that the second column is actually going up. But concavity, they don't want to look at the third column and say, are they positive or negative? They want to ask, are they increasing or decreasing? And if we're given a column and asked if it's increasing or decreasing, and we want to do this numerically, we need to add another column and find their average rates of change for that column. So I added one more column over here. We'll talk about the notation in a little while, but it is very consistent with what's going on. And all I did in the last column was find the average rates of change for the last thing. So for example, 15 minus 20 is minus 5, divided by 2 minus 1, so that's minus 5, and so on. And you can see that all these numbers on the right-hand side are negative. Now what does that tell us? That tells us that the middle column is decreasing, because when this column is negative, the middle column is decreasing. And according to the book and the video, if the middle column is decreasing, the data we're given is concave down.